Hello everyone! Today is December 29 and it's time to open a new problem from LeetCode for our Coding Advent Calendar. Today's problem is about prioritizing tasks, emulating CPU, and new cool data structure called SortedSet. Let's take a look. Here is the problem. Single-threaded CPU. You are given n tasks labeled from 0 to n-1, represented by 2D integer array tasks, where task is in queue time and processing time. So it's array of arrays, and each item array is two integers. Mean that task I will be available to process at in queue time and will take processing time to finish processing. You have a single-threaded CPU that can process at most one task at a time and will act in the following way. If CPU is idle and there are no available tasks to process, the CPU remains idle. If CPU is idle and there are available tasks, the CPU will choose the one with the shortest processing time. If multiple tasks have the same shortest processing time, it will choose the task with the smallest index. Once task is started, the CPU will process the entire task without stopping. The CPU can finish a task, then start new one instantly. Return the order in which the CPU will process tasks. Okay, here are two examples. You can look at them if you pause the video, but I will not take much time explaining how this should work. You can read it. I will go straight to a solution. So my strategy to solve this problem is first we need to sort initial tasks and sort them by in queue time. This will allow us to know in which order these tasks are getting available, taking into account idle time. So the first task which is available should be taken to process, no matter how long this processing time will take. And secondly, we need to have a data structure which will tell us which task to take if these tasks are already available, but the order in which these tasks should be taken for processing should follow these rules. And since in these rules we have special note about index, we need to also take care of the index of this task. So if we sort this initial array, we will lose initial index. So we need to extend this array to store additional value here. This is what we are going to do. So first we will extend our tasks array, so it will be array of arrays, but instead of 2 item arrays, it will be 3 item arrays. Okay, and these extend tasks will look like this. We will resize each array. And we will resize this to the length 3. Now in this array we will have additional index 2, right? Tasks I 2 equal to I. So we store initial order, initial index in these tasks. Okay, we extended it. Now we need to sort these tasks by start time. How are we going to do this? We will use array sort function. We will send tasks there, and we will define comparer which will define the rule of sorting. If A0 is greater than B0, which means starting time is bigger, we will return 1. If A0 equal to B0, we return 0, and otherwise return -1. That's it. So we sorted our initial array by starting time. Next we will create a data structure which will store our tasks which are available for processing by some special time. So they are not available all at once. Depending on current point of time, we have some set of tasks available. So we will use SortedSet for this purpose. We can use actually priority queue, but SortedSet should work as well. And I do this in a separate function to show you that this is very important part of our algorithm and to isolate it from the business logic. Okay, we need to set a comparer for this. and our comparer should take into account these rules. So if the ending, the processing time of which is index 1 of A is greater than processing time of B, then return 1. Otherwise, if processing times are the same, then we need to take into account the index, right, which is stored in index 2, right? So okay. And if if processing time is of A is less than B, return -1. Okay, that should be correct now. Next, what are we going to do next? We need to create list of tasks and define our initial point of time. Which is 0. Now, for each task which is in our task array, we will do the following. We will add this task to currently available tasks. But before we do this, we need to okay, what I will go return the order in which CPU. Okay, and the order is the index, right? Okay. So before we add this task to available tasks, we need to adjust our idle time to start of this task. And also, since we move our idle time forward, we need to make sure that all available tasks which are available right now had chance to be taken by the CPU. We will do this by using additional function which we are going to create here, and we will call this reduce. We will pass there our result, because we are going to add values to results. We need to pass SortedSet there because we need to have access to currently available tasks. And we need to have this idle time, and we need to be able to modify it like this. So how are we going to do this? We are going to take the next task from this set, we are going to remove it from this set. We are going to add this task to result. And we are going to use its index, which is index 2. And we are going to adjust our idle time to the maximum of idle time, current idle time, and next task start plus next task 1. Because if first available task is available sometime in future and there are no other tasks available yet, we need to move our idle time forward to the beginning of this task, and idle time will should be adjusted to the end of this task, because here our CPU will be busy with this concrete task, and it will be available for picking up a new task again only when this task is finished. Okay, so here we use reduce. We send result. There we send currently available tasks and our idle time. Also, it is possible that many tasks are available at the same time. That means we need to add them to our currently available tasks at the same time. While I plus 1 less than task length and tasks I plus 1 0, tasks I 0. So while there are next tasks which start at the same time, we need to add them to the list of currently available tasks, and we need to skip them from next iteration. Like this. Okay, this loop will help us to go through all available tasks and prioritize them for the CPU. But it is also possible that we finish our for loop here and we still have currently available tasks. We just need to go through them and reduce them one by one. And that should be it. Let's try. Unknown network error. Okay, another try few hours later. Okay. Yes. Reduce. Okay. Both cases work. Let's submit. Done. We beat 97% of all submissions. So the time complexity of our problem is big O of n log n, because we need to sort, and we use priority queue or sorted set, which is the same for our case. And memory consumption is big O of n, because we need to have additional collections which are of size of n. This problem was not actually very complicated, and you can use priority queue instead of sorted set here. The difference between sorted set and priority queue is that in priority queue you can have identical items in it. In sorted set you can't. We have only 2 episodes in this year, so see you tomorrow. Don't miss 2 last episodes.